हेलो एवरीवन, वेरी गुड इवनिंग। हाउ आर यू गाइस? तो अब आपको 15 का एग्जाम है, इलेक्ट्रॉनिक्स एंड टेलीकम्युनिकेशन, और ईडीसी इज इम्पोर्टेंट सब्जेक्ट। और ईडीसी में भी एक टॉपिक है, दैट इज फर्मी लेवल। तो आज कुछ इंपॉर्टेंट प्रीवियस ईयर क्वेश्चन सॉल्व करेंगे। तो इन प्रीवियस ईयर क्वेश्चन से आपको फर्मी लेवल के बारे में डिटेल पता चल जाएगी और आप क्वेश्चंस को सॉल्व कर पाएंगे। तो लेट मी नो दैट साउंड क्वालिटी, पिक्चर क्वालिटी, एवरीथिंग इज फाइन। यस प्लीज, एक बार ज़रा इन्फॉर्म कर दीजिएगा कि क्या सब कुछ बढ़िया है। ओके, दिस इज अ फर्मी लेवल गाइस। ओके देन, आई थिंक एवरीथिंग इज फाइन नाउ। So today we are going to discuss what Fermi level important previous year question. Okay, first of all that is my introduction. Myself Sanjay Rathi, 24 years of teaching experience. इसके साथ ही साथ आप लोगों के लिए बार का भी नोटिफिकेशन आ चुका है, अब एग्जाम भी है, ज़्यादा दिन नहीं बचे हुए हैं। तो राज, हाउ आर यू? Then this is my introduction. I have qualified and selected for engineering services exam. बार्क में आपको दो चीज़ों का ध्यान रखना पड़ेगा। एक तो गेट, अभी अब तो गेट दे दीजिए 15 को, उसके बाद इंजीनियरिंग सर्विसेज एग्जाम और गेट के आपको प्रीवियस ईयर क्वेश्चन सॉल्व करने हैं। उसके बाद आपको इंटरव्यू के लिए प्रिपेयर करना है, इंटरव्यू में अच्छे क्वेश्चन पूछे जाते हैं। ओके, तो देन अब आप देखिए जरा, दिस इज माय चैनल इलेक्ट्रॉनिक्स बाय संजय राठी। तो ऑल द न्यू स्टूडेंट प्लीज ज्वाइन दैट, लिंक इज गिवन इन डिस्क्रिप्शन, एंड इंस्टॉल ऐप दैट इज प्रेप फंडा बाय संजय राठी। तो वहां पर आपको बहुत सारी फ्री क्लासेस दिखेंगे, तो आप ज्वाइन कर लीजिए, क्योंकि बाद में भी कुछ ऐसे सब्जेक्ट हैं जिनका मैं अलग से सेशन लूंगा और आप लोगों को इंटरव्यू गाइडेंस भी रेगुलर बेसिस पे मिलता रहेगा। ओके, तो ये है टेलीग्राम चैनल। ऐप का भी लिंक आपको डिस्क्रिप्शन में दिया हुआ है, वहां से आप ऐप डाउनलोड कर लीजिए। गो थ्रू द प्रीवियस ईयर सेशन, गो थ्रू द नोट्स, इट विल हेल्प यू। एंड गाइज आप लोगों के लिए बस अब जो है 2026 2027 इंजीनियरिंग सर्विसेज प्री 2025, अगर आप प्रिपरेशन स्टार्ट करना चाहते हैं जो कि जून में होगा, तो आई एम गोइंग टू प्रोवाइड कोर्सेज फॉर इलेक्ट्रॉनिक्स, इलेक्ट्रिकल एंड इंस्ट्रूमेंटेशन ब्रांच। डाउनलोड ऐप नाउ, एंड फॉर मोर डिटेल यू कैन कॉल एट दिस नंबर 9899940096। मैसेज मी और कॉल मी। ओके, बट स्टार्ट योर प्रिपरेशन। यहाँ पर आपको मिलेगा लाइव सेशंस, रिकॉर्डिंग्स, प्रीवियस ईयर क्वेश्चंस, क्वेश्चंस फ्रॉम द टेक्स्ट बुक, एंड कोर्सेज इन इंग्लिश एज वेल एज इन हिंदी। राइट, इंग्लिश बैचेस हैं पूरी सेपरेट, प्लस व्हाट, हिंदी। हिंदी मीन्स इंग्लिश जो बोलते हैं हम लोग, दैट इज द लैंग्वेज। ओके, इंग्लिश वही टेक्निकल तो इंग्लिश में रहेगा। आई एम फाइन राज। देन चलिए स्टार्ट करते विदाउट एनी डिले। दैट इज द फर्स्ट क्वेश्चन, एवरीवन ट्राई टू सॉल्व दिस क्वेश्चन। कंसीडर टू एनर्जी लेवल, दिस इज द फर्मी लेवल। Without wasting your time, this is the Fermi level. Consider two energy level, E1 that is the E electron volt above the Fermi level, and E2 E electron volt below the Fermi level. P1 and P2 are respectively the probabilities of E1 being occupied by an electron and E2 being empty. Right? Then tell me, what is the answer? What is the answer for this question? तो पहले तो क्वेश्चन ही समझ लो पूछा क्या है। ओके, यहाँ पर हम एक डायग्राम बनाएंगे। यस, कंसीडर द टू एनर्जी लेवल E1 E इलेक्ट्रॉन वोल्ट अबव द फर्मी लेवल। राइट, तो चलिए फर्मी लेवल कहाँ होता है नॉर्मली? ये आपका दिया हुआ है कंडक्शन बैंड, ये दिया हुआ है वैलेंस बैंड के लिए लाइन EV, और यहाँ कहीं है आपका फर्मी लेवल मिडिल में। कंसीडर टू एनर्जी लेवल E1 E इलेक्ट्रॉन वोल्ट अबव द फर्मी लेवल, तो यहाँ आ जाइए अबव द फर्मी लेवल। E2 E इलेक्ट्रॉन वोल्ट बिलो द फर्मी लेवल, सेम आपका बिलो यहाँ पर आ गया। राइट, फर्मी लेवल। P1 and P2 are respectively the probabilities of E1 being occupied by an electron and E2 being empty. ठीक है, E1 कहाँ है? यहाँ है। This is the above and this is below. Same ऊपर है E1 E below the Fermi level, and P1 and P2 are the probability of E1 being occupied and the electron at E2 being empty. अब देखो E1 अगर बोल रहा है It is occupied and empty. Means what? It may be in what? In which region? In a conduction band. Suppose this is the energy level in conduction band. Just I am saying that this energy level is, because in forbidden energy band there will be no charge carrier. So let this is the E1 inside the conduction band, and this is the E2 inside the valence band. One electron will get sufficient energy and switch from valence band to conduction band. So what is the probability of finding an electron at E1? This is the P1. So what is the probability of finding an vacancy in what? Valence band. Again it is a P1, same probability. So this is the P1, the probability of E1 being occupied. This is occupied by the electron. And E2 being empty. This is the empty. So what about the probability? Same. Actually empty means what? Holes. When we are giving the sufficient energy, it will switch from what? Valence band to what? Conduction band. So these two are equal. And this is not this energy levels inside the conduction band, because electron will be inside the conduction band, and this is what? Inside the valence band. And what about this? This is called forbidden energy band gap. Forbidden energy band gap means no hole and electron will exist there. Okay. So no hole and electron will exist in that region, guys. So you can remove that. E1 and E2. Okay. This is a very simple 1987. It is of 2 marks question. Now it may be what? MSQ. Then I think it is clear. If you find any difficulty, any doubt, then please ask me in comments box. I will clear it, because this is very important topic. Fermi level, right? तो Fermi level EDC में से आएगा. इलेक्ट्रॉनिक्स वाले थोड़ा तैयार हो जाओ भाई. Now second, with questions you will get all the formula. I am going to discuss each and every formula. The probability that an electron in metal occupies the Fermi level at any temperature. Okay, I want to give you one information. If you want to revise all the formula, you can join tomorrow morning. That is the Saturday, right? Morning, I will share the link on my Telegram channel. You can go through my YouTube session. Complete marathon on what? EDC. Where we will cover what? First diode, then PN junction, and then third thing is what? Important, that is MOSFET. Marathon session, all the formula we are going to discuss, guys. Good evening, sir. Oscillator from, if you want one session on oscillators, which type of oscillator? Tell me. Matlab means there are two types of oscillator. Now one is what? Sinusoidal oscillator, and another one is what? Stable multivibrator square wave generator. That is also generator is oscillator. So sinusoidal oscillator you want? Now tell me what is the answer? What is the answer here? So what is the formula? Probability. The formula is given by Fe is equal to 1 upon 1 plus e raised to power E, that is the energy level, minus Ef. This is the Fermi energy level upon what? KT. Upon what? KT. What is given here? Probability that an electron in metal occupies the Fermi level. Fermi level means E is equal to Ef. So irrespective of the temperature, E minus Ef will become what? 0. If the E minus Ef will become 0, this is 1 upon 1 plus e raised to power 0. That is nothing but 1 by 2, 50%. What is the probability here? 50%, 0.5. Very simple question. That is what? 0.5. Okay. Is it audible? Everything is fine. This is 0.5. So remember, this is the formula. This is the formula here. Probability distribution function or probability function Fe. Okay. Then. Okay. Then next is silicon is doped with boron. What is the boron? Trivalent or pentavalent? Everyone tell me. What is boron? Trivalent or pentavalent? To a concentration of 4 into 10 raised to power 17. Assume that the intrinsic carrier concentration of silicon to be this much. Ni. This is the Ni given. You can write here. Na? Ni. For example, this is the Ni. What is the Ni? 1.5 into 10 raised to power 10. That is the fixed value for silicon. But it may change. Kt by Q is nothing but Vt. What is the Vt? 25 millivolt. or 0.025 volt at 300 degree Kelvin compared to the undoped silicon, the Fermi level of the doped silicon. It is the boron. Boron is what? Trivalent. This is an acceptor. 4 into 10 to the power 17 atoms per centimeter cube. This is the density. So boron acceptor, when we are giving acceptor, it will accept one electron and create holes. So holes means Fermi level will be near to valence band. Assuming the intrinsic carrier concentration is given, Kт by Q is given, compared to undoped silicon, the Fermi level. Now how to solve this question? So simple, remember guys, this is the standard formula. Now this is EV, this is EV, and that is the Fermi level for intrinsic semiconductor, right? This is the Fermi level for intrinsic semiconductor. Since we are giving the boron, this is conduction band, EC, EV, and this is the middle, EFI, intrinsic Fermi energy level. Now, what about the Fermi level? Fermi level will lie here, near to what? Valence band. Why boron? Boron is what? Trivalent, and that's why it will become P type. So this is actually the Fermi level. Okay. Now this gap, remember the formula for this gap, EFI minus EFP, it will goes down as compared to intrinsic Fermi level. So this is the Kt log of EFI minus EFP, Kt log of Na upon what? Na upon Ni, or this is actually formula is what? P upon Ni. P means concentration of holes upon Ni. That is the gap. So EFI minus E. So what you can find, what is the Kt? Kt by Q, so that is in electron volt, that will become 0.025 electron volt. That is the value of the Kt is given, 0.025 electron volt. Log of, what is the Na? What is the concentration of boron? 4 into 10 raised to power 17. And what is the Ni? 1.5 into 10 raised to power 10. And then you can find the answer in what? Electron volt, because it is in electron volt. It is goes down by this much electron volt, guys. You can find the value. Please find the value and give me the answer. Below. Yes, it is below. Goes down. Okay, goes down. So that is the formula. Very, very simple. Now suppose with this is the Kt log of Na by Ni. What is this gap? EFP minus EV. EFP minus EV. If it is given EFP minus EV, then you have to use what? Density of state actually. Or how we can find? Remember, suppose this gap, you have to find this gap. So what is the total forbidden energy gap is given? Sometimes it is the total forbidden energy gap is given. So we will solve one question. This is a very, very important one. Let, for example, this gap is given. For silicon, it is what? 1.1 electron volt. This gap is from this point to this point, it is 1.1 electron volt. So what is the half gap? Half gap will become Eg by 2. So what is the Eg by 2? 1.1 divided by 2. Right, 1.1 divided by 2. Now, if you have this value, Kt log of Na by Ni, then you can find. Then how we can find this gap? Eg by 2 minus that. So what is this gap? Eg by 2 minus of what? Kt log of Na by Ni. Because in this question Na is given, Ni is given, Kt is given, or that the gap is, suppose the gap is given, the forbidden energy gap for silicon is 1.1 electron volt, then you can subtract this gap and you can find this one. Otherwise, what is the formula here? For this reason, you have to find the standard density of state. Standard density of state means there is a formula, this gap, EFP minus EV. EFP minus EV. This gap is Kt log of Nc by what? Nc nahi, this is a NV, standard density of states for holes in a valence band, that is the NV. By what? जो, that is the concentration of that is given, NV by Na. NV by Na. Na is the concentration of, or NV by P actually. P means concentration of holes. So P is nearly equal to what? Na. This is the gap. So this gap Eg by 2 minus Kt log of Na by Ni is equal to what? Kt log of Nv by Na. Okay, any doubt here? Any doubt here? So with one numericals, this much formula guys, this much formula, and you have not given me the value. This is down by how much? या थोड़ा कैलकुलेटर अपना वर्चुअल कैलकुलेटर यूज कर लो जरा. कैलकुलेशन भी आप मुझसे करवाना चाहते हो, कर लेंगे, वो भी कोई दिक्कत नहीं, लेकिन आप भी कैलकुलेटर का यूज कर लो. Then this is the EFI minus EFP. Fermi level for P type 0.427. So this will become 1.1 divided by 2 minus 0.427. You will get the answer EFP minus EV also. Okay. Next question. 0.427 electron volt. बहुत बढ़िया. Next one. Okay. This is the graph. Actually, in Millman Helkias, in what treatment and energy, some graphs are given. So, sometimes we are getting the question on graph. Last year again there was a one question on graph. Please go through all the graphs. Otherwise, I am going to take one session where I will give you the idea about all the graphs, guys. So this is the graph. Temperature is fixed. What is given? A piece of silicon is doped uniformly with phosphorus. What is phosphorus? Phosphorus, write down the pentavalent or trivalent, with a doping concentration of 10 to the power 16. That doping is given 10 to the power 16. The expected value of the mobility, this is the mobility curve, this is the whole electron mobility, this is the mobility of electron, and this is the mobility of holes. Always remember, the mobility of electron is greater than mobility of holes 2 to 3 times. Here it is a 2 to 3 times. The expected value of the mobility versus doping concentration, this is the doping concentration here. It is actually what? 10 to the power 13. This is 10 to the power 14, 10 to the power 15, 10 to the power 16, 10 to the power 17, 10 to the power 18, 10 to the power 19, and 10 to the power 20. That is called doping. How much doping? The expected value of the mobility versus doping concentration for silicon, assuming the full dopant ionization. Full dopant ionization means, suppose you are giving the Nd is equal to what? 100. For example, so everyone will ionize and they will provide what? 100 electrons. This is called what? Everyone will give 1 electron, and that is called what? 100% equalization. 100% what? Ionization. Okay, 100% ionization. Now 10 to the power 16. 10 to the power 16 means there will be what? 10 to the power 16 per centimeter cube number of electrons. The expected, this is a phosphorus. What is the phosphorus? It is a pentavalent. Pentavalent means donor. It is actually the concentration of what? Nd. What is the Nd is given? 10 to the power 16. Everyone will give the 1 electron. Every donor atom will give the 1 electron. So what should be the concentration of electron? 10 to the power 16 per centimeter cube. Then silicon, full dopant is shown in the figure. The charge of the electron is 1.6 into 10 raised to the power minus 19. The conductivity, it is asked. So it is how it is related to what? Fermi level. I will give you the idea. But first of all, conductivity. Very simple question. Conductivity means what? Sigma. It is a n type because phosphorus is given Nq mu n. N is nothing but Nd. Nd you have. Q means 1.6 into 10 raised to the power minus 19 coulomb. What is the mobility? What is the concentration here? 10 to the power 16. Remember, again at 300 degree Kelvin, when we are increasing the doping, What about the mobility? Mobility start decreasing, and this is called impurity scattering, guys. This phenomena is called impurity scattering. It is a impurity scattering. Now watch this. It is the concentration at this point. This is the value at this point. So what is the mobility here? 1200. From the graph you will get the mobility of electron is 1200. So what is the logic here? First of all you have to decide phosphorus. Phosphorus is pentavalent. Then mobility curve. There are two mobility curve. One for hole, one for electron. You have to choose the curve for what? Electron. Because it is a pentavalent means it is n type. Suppose it is not given. Let this is not given. It is for electron, it is for hole, it is not given. Then again guys, always remember the mobility of electron is greater than mobility of holes. And that's why the above curve is for electron and below curve is for holes. It may possible that it is not given. Then sigma. So Nd into 1.6 and mu n is 1200 centimeter square per volt second. This is the 1200. Because the concentration in centimeter, so this is the 10 to the power 16 into 1.6 into 10 raised to power minus 19 into what? 1200. Multiply it and you will get the conductivity. Very easy question. So that is the role of the graph, guys. From the graph you have to solve the question. Okay, then next one. Next on the Fermi level. This is a very simple calculation. Now multiply and you will get the answer. Okay, easily you can multiply it. अब क्या पूछा है? Single crystal intrinsic semiconductor is at temperature of 300 degree Kelvin. A single crystal intrinsic semiconductor with an effective density of state. This is called effective density of state, NV. Normally NV is greater than Na, Nc. Twice of that of the electron. So twice of that of electron means Nc. That is the standard density of state in conduction band. This is the standard density of state in valence band. Thermal voltage, that is the Vt, Kt by Q, is given by 26 millivolt. Okay, that is the 0.026 volt. The intrinsic Fermi level is shifted from the mid band gap energy level by there is no doping, guys. There is no doping. Again the Fermi level will shifted from the mid band gap. So what is the formula here? What is the formula here? Right, tell me. 1 minute. I need blank slide. Okay. So this is the formula. Now watch this. This is given. This is EC. This is EV. This is middle. Right. This is nothing but EC plus EV by 2. This is EC. This is EV. This is EC plus EV by 2. Exactly in middle. Right. But where is the Fermi level? For intrinsic, Fermi level is EC plus EV by 2 plus KT log of NV by NC. That is the KT by 2 log of NV by NC. That is the Fermi level actually. But normally what we are doing, we are taking the effective mass of hole is equal to what? Effective mass of electron. Normally these are called effective mass of hole and effective mass of electron. We are getting equal. Therefore we are taking the NV is equal to what? NC. When the NV and NC are equal, this term will become what? 0. And that's why we are saying that it is in the middle of the forbidden energy gap. But actually if the NV and NC, normally what will happen? The effective mass of hole is greater than effective mass of electron. And that's why the mobility of hole is less than the mobility of electron. That is the reason. If the suppose the mass is high, mobility will be less. Mass is high and that's why the mobility is less. Or it depends. Okay. Mu p is less than mu n. This is the reason. Normally this is the effective mass. or if nothing is given, we are taking effective mass are equal. Now, Kt by 2 log of Nv by Nc. Nv depends upon that Nc. More will be the effective mass, more will be the Nv. So 2 times. The Nv is 2 times of Nc. So you can write here, you have to find the Kt by 2 log of 2 Nc by Nc log 2. Or Kt by 2 is given as 0.026 by 2 log 2. What is the log 2? 0.693. It will become 0.013 into 0.693. Find the value. So that is the gap. That is the gap. Actually, it is situated here, slightly above the middle. EC plus EV by 2. Then remember the formula, please. This is important formula. Okay. Any doubt in this question? Any doubt, then yes, you can ask. Okay, up to this point, everything is fine. Okay, next one. Next is the band gap of, next question, this is required. What is the band gap of silicon at 300 degree Kelvin? What is the band gap of silicon, EG? Which answer is correct? 1.16 electron volt, 1.10 electron volt, 8.80 electron volt, and 0.67 electron. Very, very easy question. Tell me what is the answer. EG is nothing but EG0 minus beta T. Right? Beta has a value, no need to mug up. EG0 and EG you have. At the room temperature, means at 300 degree Kelvin, you have the value of EG. And at 0 degree Kelvin, you have the value of that EG naught. What is the EG naught? 1.2, 1 electron volt. And at room temperature, it is what? 1.1 electron volt. So from that, you have this value, you have this value, you have the 300 degree Kelvin, you can find the value of the beta. Means temperature increases, band gap decreases. That is the value. 1.1 electron volt. That is called forbidden energy gap. Then now, given the Fermi energy is 0.25 electron volt below the conduction band, assume that the system is in the equilibrium. The standard density of state is given, Nc is given, Nv is given. This time Nv is less than Nc. This time in this particular question, Nv is less than Nc, it is given. Okay, no problem. Means effective mass of hole is less than effective mass of electron. Then Ni is also given. The value of the electron concentration in silicon, electron concentration in silicon at a 300 degree Kelvin is, at a 300 degree Kelvin is, what is the concentration of electron, guys? You have to find the concentration of electron. This is the Fermi level. Where is the conduction band? Valence band. Now this is EC. What is given here? Fermi level is 0.25 electron volt below the conduction band. Okay. Conduction band means here it is the value. What is the gap here? 0.25. It is the EF. It is near to conduction band, means it is N type. And this gap is given as 0.25 electron volt. This gap is given as 0.25 electron volt. Nv, Na, Ni is given. The value of the electron concentration in the silicon at 300 degree Kelvin is. So guys, what is this gap EC minus EFN? What is the formula here? EC minus EFN is equal to, this gap is KT log of NC by what? Ni. NC by N. NC by N, where N is the concentration of electron. Right? NC by N. EC minus EFN. EC minus EFN just below the conduction band. It is given 0.25. What is the KT? KT is given at 300 degree Kelvin. What is the value of the KT? That is what KT by Q. We have the VT is equal to what? 0.025, 0.026 electron volt, 0.026 volt. So KT will become KT, because it will become 0.026 electron volt, because it is a KT by Q. When it is multiplied with the Q, or that is what energy will become 0.026 electron volt, smaller unit of the energy, log of NC 2.8 into 10 raised to power 19 divided by N. You have to find the N. Take here, then take the anti-log guys, anti-log of that, and then finally find the value of what? N guys. Value of N. Can you find? Yes, tell me. Calculate it. So definitely it is below, means what? It will be less than what? 10 to 2.8 into 10 raised to power 19. So all the answers are less than 2.8 into 10. It is a 10 to the power 15. It is a 10 to the power 14. It is a 10 to the power 16. It is a 10 to the power 17. You have to calculate the log. It is nearly equal to what? 10. Anti-log of 10, and then find the value of N. Anti-log means natural log. You have to find the natural log guys. निकाल लोगे? Yes or no? Tell me, otherwise tell me. Use your virtual calculator. Only virtual calculator ना, साइंटिफिक कैलकुलेटर तो एग्जाम में भी अलाउड नहीं है. बताओ क्या होगा आंसर? What is the answer here? One point eight into 10 raised to power 15. Yes, A. A is the answer for this particular question. Okay. Now next question. So this is the formula. In this way you will get the idea what is the formula here. This gap is what? KT log of NC by N. Now, so already we have solved this question. I think it is a misprint. Okay, no problem. Already we have solved. This is the answer. Goes down by. Now, an N-type semiconductor has its Fermi level at 0.25 below the conduction band. Right? Similar question. Now this time it is given N-type semiconductor has its Fermi level at 0.25 electron volt below the conduction band edge. What is the conduction band edge? EC. If the density of state in conduction band at room temperature, again it is density of state is given. Similar question but language is different. Same question. Density of state in conduction band means what? NC. The majority carrier concentration, again you have to find the electron guys, N. So 26 is given. So same formula. This one. Right? Same formula. This is given. This is given. Log. But you have to change this value. You can solve. This is the homework for you. Please give me the answer. Right? So what is the gap here? 0.025. It is called EC minus EFP. EFN is equal to KT log of NC by N. N type now, so majority charge carrier is N. This is given as 0.25. This is given as 26 millivolts. Same question. log of NC, there is a change in the NC, and then you can find what n. Okay, again you have to find the log and then divide it and you can find the value. Easy? Okay then. Find the value of n. But remember, this is the 10 to the power what 20. Last, this is the in what IT G mains examination. Some students are doing the silly mistake that what the answer was 7.7. Na? It is given x by 1000. Q is x by 1000. That try to understand. Na? Only last line is Q is x by 1000. So what is x? So x is equal to x is equal to. So in a particular question, you have to find a Q. So write Q is what? 7.7. Tell me. If the Q is 7.7, so what is the value of X? Q is X by 1000. So what is the value of the X? 1000 times of Q. That will become what? 7700. And that is the answer. Some student put this. This last word is not clear. What is the this? They have find the Q and just put the value 7.7. So please take care of that. Na? That is similar type of questions we are getting. This is in a question what? Mains examination. Mains. Mains means G mains. Okay. Now, in a semiconductor device, this is the question from the ISRO examination. In ISRO, question marking is what? 3. 80 questions. Every question is of 3 marks to 240 marks. In a calculator not allowed. No? Calculator not allowed. But again, in a semiconductor device, if the Fermi level is positioned at conduction band, Fermi level is positioned at conduction band, determine the approximate probability of finding electron in state at EC plus KT, where K is the Boltzmann constant and T is the device temperature, guys. Now watch this. Right? You have to find the probability of finding electron in the state at EC plus KT. Where is the Fermi level? Is positioned at the conduction band. So what is this? Is the Fermi level. Conduction band, when we are saying that it is in a conduction band, this is it is just a conduction band at the edge of the conduction band. Right? This is the EV. Now Fermi level is at the same energy level EFP, EFN, because it is towards the conduction band. This is the N type. Now where is the energy level? This is the energy level. Right? EC plus KT means inside the conduction band, and you have determined the approximate probability of finding electron in the state EC plus KT. Now which answer is correct? So probability density function, guys, probability density function Fe is equal to 1 upon 1 plus e raised to power E minus EF by KT. That is the formula. E minus EF by KT. So first of all, what is the E minus EF by KT? What is the E? EC plus KT. This is the E minus. Where is the EF? At conduction band. It is, you can write the EC upon KT. Right? EC cancel. It will become what? KT by KT. What is the KT by KT? 1. KT by KT is 1. So it will become probability of finding an electron will become 1 upon 1 plus e raised to power 1. Now, what is the value of the e raised to power 1? What is the value of the e raised to power 1? If you have the value, then you can directly divide it and you can find the value. Here, tell me. 2.718. 2.718 is the value of, that is the around 0.268. Determine the approximate probability of finding electron in the state EC plus KT. So that is, we are getting 0.268. It is nearly equal to what? 0.27. So in a particular numerical, in a ISRO, they will provide this value. For example, e raised to power plus 1 is So language, read question carefully. EF is positioned at conduction band. This is the EC. This is given also EC. Determine the approximate probability of finding electron in at the state EC plus KT means it is inside the conduction band. K is the Boltzmann constant and T is the device. Use the formula and put the value. Formula based question. Formula based question, guys. Now, a silicon N-type semiconductor is doped with donor impurity of 10 to the power 16. Directly it is written. Donor, it is N-type, it is also given. Donor means ND at room temperature. If the intrinsic concentration is 10 to the power 10, then the gap between the Fermi energy level and intrinsic energy level. What is the gap between the Fermi energy level and intrinsic energy level? Tell me. What is the gap between the Fermi energy level and intrinsic energy level? It is N-type. It is N-type. This is the EC. This is the intrinsic Fermi energy level. Intrinsic energy level. This is the intrinsic energy level. Where is the Fermi level? Here, near to conduction band. Near to conduction band. This is EC. This is the EFI. And this is EFN. Because it is N type. This gap, KT log of, very simple, KT log of ND by NI. What is the KT? At room temperature it is given. You can put 0.026 log of 10 to the power 16 divided by 10 to the power 10. That will become 10 to the power 6. Now you can find okay. Point 36 बिल्कुल सही. This is the right answer. It is given B. B for Bombay. 0.36 इलेक्ट्रॉन वोल्ट. बिल्कुल सही. देख रहे बार बार फॉर्मूला बेस्ड क्वेश्चन है. नो थोड़ा सा अलग भी आएगा. वेट फॉर दैट. With increase in the temperature for p-type semiconductor, for p-type semiconductor, if suppose I am going to increase the temperature, what is the true with regard to the Fermi level? So we can get what MSQ type question, but here it is MCQ. It reaches the valence band, p-type semiconductor. So where is the Fermi level? Fermi level is near to what valence band? So what about the Fermi level? It reaches the valence band, it reaches the conduction band, it reaches the center of the forbidden energy band gap, it disappears. It disappear. There are 4 options, guys. There are 4 options here. Then tell me which option is correct. Okay. So when in a p type, it is in a p type. Focus on the formula here, otherwise it will confuse you. क्या करना है देखो भैया, ये देखो ये आ गया, ये आ गया, ये है मिडिल वाला लेवल. और वेयर इज द फर्मी लेवल? दिस इज द फर्मी लेवल फॉर p type. B and C both. Okay. MCQ है, this is the EFI and this is the EFP. Now what is this gap? EFI minus EFP is given by KT log of this gap, na? Na by Ni. KT log of Na by Ni. This is gap. So according to this formula, if suppose you are focusing on this one only, so when we are increasing the temperature, the gap will increase and it is moving towards what valence band you can say. Moving towards valence band you can say. But remember, what is this gap below? This gap is Kt log of, right, Nc by what? Kt log of Nc by N, or we can say concentration Na. We are not changing the Na, we are just changing the temperature. Nc also depends upon the temperature, but when we are increasing the temperature according to this is moving upward, and this is according to this is moving downward. But guys, remember, Ni also depends upon what temperature. Ni square is proportional to what? T raised to power 3. A naught T raised to power 3 e raised to power minus Eg0 by Kt. That is the formula for intrinsic carrier concentration. When we are increasing the temperature, this term will increase, but because this term will also increase, what is the overall term? Overall term will reduce, means this gap will reduce, guys. This gap is reduced, and this line is moving towards what? Intrinsic Fermi energy level. Second thing, remember concept. If we are increasing the temperature, new hole electron pair will generate. If the new hole electron hole pair will generate, then guys, definitely hole will increase, electron will increase. It means now no doubt it is initially it is p type, now it is converted into what? Intrinsic type. More will be the temperature, more will be it what? Like a intrinsic type. So remember in this formula Kt, but here in a denominator Ni also depends upon the temperature, or here you can directly focus on the T. When we are increasing the T, this gap will increasing and this is moving towards what? Intrinsic level, that is in between EFI, towards EFI. It is not going toward the conduction band, because we are not increasing the doping, we are increasing the temperature. That's why it reaches the center of the forbidden energy band gap. Or you are saying that it reaches the conduction band. No, 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 it is not possible. Because when it reaches up to what? Middle level, it is converted into what? Intrinsic type. Then how the electron will generate? When we are increasing the temperature, always remember electron hole pair generated. Electron hole pair generated means it will remain what? Intrinsic type. That's why the answer for this question is C for Kolkata. Okay. Now, next question. All are selected question here. Once you will get the idea, Fermi level. Then, an intrinsic semiconductor is doped with an impurity concentration of 10 to the power 16. Again, intrinsic. It is not given whether it is a p type or n type. It may be p type, it may be n type. Assuming the intrinsic carrier concentration is this much, the thermal voltage is this, the Fermi level in doped semiconductor. Guys, no need to calculate the value, because in every formula value is given same 0.35, 0.35, 0.35, 0.35. Whether it is Na type, whether it is a Nd type, both type of given. Third group element, fifth group element, fifth group element. Third group element means what? Na. If the Na is given, always remember it will goes what? Down. It will goes down. It is a goes down in third group. So this is the goes down by the 0.35 electron volt. If the third group, it is A is correct, B is wrong. Because in case of third group, it is never goes up. It will goes down. Right. Second, if it is Nd, donor impurity, it is moving towards the conduction band. It is what? Fifth group, pentavalent. It is what? Trivalent. Goes up by the 0.35, the impurity is fifth. So what is the answer? It is MSQ. What is the answer? MSQ. What is the answer for this question? A and D. No need to calculate the 0.35. Otherwise, you want to calculate, then yes, you can use the formula, that is what? Kt log of, if it is Na by Ni or Nd by Ni, you will get the gap. you will get the gap also. So in a group 3 down, group 5 up by same amount. That's why you no need to calculate. A and D is the answer. MSQ. Now tell me what is the answer. A small percentage of impurity is added to an intrinsic semiconductor at 300 degree Kelvin. थोड़ा सा आपने डाला impurity small percentage. Which one of the following statement is true for the energy band diagram shown in the following figure? Guys, it is not a question on what Fermi level. It is a conduction band and new energy level is created here. New energy level is created means what? Yes, Raj. Answer is A and D. New energy level created means this is called in a near to what conduction band EC. This is the EC. This is the EV. So near to conduction band, it is called donor energy level ED. Or near to valence band, it is called acceptor energy level, guys. Right? Acceptor energy level and donor energy level. Watch this. Now watch this. This is called acceptor energy level and this is called what donor energy level in N type. Then this gap. This is ED and this is EC. This is EA. Acceptor energy level and this is the EV. Right? Now, which answer is correct? A new energy level. 300 small percentage of impurities added to the intrinsic level. Which one of the following statement is true for the energy band diagram shown in the figure? New energy level it is created. Intrinsic semiconductor doped with pentavalent atoms to form the n-type semiconductor. बिल्कुल सही, because it is the n-type. Intrinsic semiconductor doped with trivalent atom. When we are adding the trivalent, it will become what p-type. So that's why it is wrong. Intrinsic semiconductor doped with pentavalent atom to when we are adding the p pentavalent, it is not p-type. It is n-type. Wrong. Doped with the trivalent to form the p-type. This statement is right. Intrinsic semiconductor doped with pentavalent atom to form the p-type semiconductor. But according to diagram, it is a donor energy level. And that's why we are adding what? A. So this is wrong. Answer for this question is A. So this is not based on what Fermi level. It is what discrete energy level, donor energy level or acceptor energy level. Very small amount of energy is required to move the electron from this energy level to what conduction band. Only 0.01 electron volt. And just to move the one electron from valence band to conduction band, how much energy is required? Minimum 1.1 electron volt is required. As compared to 1 electron volt, it is very less in case of silicon, guys. Case of silicon or germanium. Okay, very less. And once the electron move from this point to this point, this is called extrinsic excitation. This is what extrinsic excitation. And when the electron is moving from valence band to conduction band, this is called intrinsic excitation. Intrinsic excitation. There may be the question, intrinsic excitation, this much amount of energy is required. Extrinsic excitation, this much amount of energy is required. What is the ratio of that? This type of questions we can assume. Next one. Now, this is the question from what is standard textbook, guys. So try to solve this. I will give you the hint. Tomorrow morning I have session. Tomorrow I will solve this question. But I'm giving you the hint, guys. In a very long P, this is the question from standard textbook. That is what is treatment and Banerjee. And that is on the Fermi level. I think this type of questions we may expect in GATE 2025. In a very long P-type silicon bar with cross-sectional area 0.5 centimeter, area is given. Na means acceptor impurity, 10 to the power 17 it is given per centimeter cube. We inject a hole, right? It is already p-type bar. We inject holes such that steady state excess hole concentration is 5 into 10 to the power 16 at x is equal to 0. Steady state excess hole concentration. What is the steady state separation between Fp and Ec? Fp means Fermi level for p-type and Ec conduction band. At 1000 Armstrong, what is the whole current there? What is the whole current there? How much is the excess stored hole charge? Excess stored hole charge. Assume that the mobility is 500 centimeter square per volt second and mean lifetime tau p, this is the tau p actually, is what 10 to the power minus 10 seconds. Right, 10 to the power minus 10 seconds, mean lifetime. Yeah. Then how we can find? Remember, in this question, if this is the bar, for example, right, this is the bar, okay. Now already there is a uniform concentration of what, 10 to the power 17. You can write this 10 to the power 17. This is the uniform concentration. Now what is the excess hole concentration at x is equal to 0? This is x. This is the 10 to the power 17 is the uniform concentration of holes. What is the excess hole concentration at x is equal to 0? 5 into 10 to the power 16. Injected holes such that the steady state excess hole concentration is 5 into 10 to the power 16. Excess means from this point to this point, this gap is what, 5 into 10 to the power 16. So total hole concentration will become 10 to the power 17 into 5 into 10 to the power 16. Now when we are moving from this point to this point, this excess hole concentration will reduce. And finally it will become equal to a 10 to the power 17. Now this excess hole concentration, so what is the total hole concentration at x is given by 10 to the power 17 plus what, 5 into 10 raised to power 16 e raised to power minus x by what, LP. It will follow this formula where LP is called diffusion length, guys. LP is called diffusion length. Now, so at this point, at x is equal to what, 1000 Armstrong. First of all, convert. Always remember 1 Armstrong is equal to what, 10 to the power minus 10 meter. Or you can say 10 raised to power minus 8 centimeter. First of all, convert it into centimeter. And find the LP in centimeter. LP is what, diffusion length. What is the formula for the LP? Root over dp tau p. dp is the diffusion constant. Tau p is given. Where is the dp? You have to find the dp from what, Einstein equation. dp by mu p is equal to what, Vt, volt equivalent of temperature. So volt equivalent of temperature, at room temperature you have the value 0.026. 0.026 you can use and multiply with the mu p. Mu p is given in the question. Yes, mu p is given in the question. So you can find what, dp. From dp, tau p is given dp. You can find the lp. From the lp or x, you can find the actual hole concentration at x is equal to 1000 Armstrong. Once you have the actual hole concentration, then given what is the steady state separation between Fp and Ec at x is equal to 1000 Armstrong, right? And what is required here? 1 minute. Ni for silicon, what is the Ni? 1.5 into 10 raised to power 10 per centimeter cube you can use. Ni it is used, you can use, right Dilkas? Or Now just watch this. I'm giving you the diagram also to try to solve. Tomorrow morning I will solve this question. Na? Now this is a very important from the treatment and energy, all the concept used here. Now watch this. That this is the bar, right? Here this is the EV, this is the EC. Now let this is the x is equal to 0. When we are moving here, x will increase. So exactly at x is equal to 0, the concentration of hole is very high. Concentration of hole is very high. That this is the intrinsic Fermi level. And the concentration is high, Fermi level will be near to what? Valence band. When we are moving away, then excess hole concentration will reduce, overall concentration will reduce. So which type of Fermi level we are getting? This type of Fermi level we are getting. It is moving away from what? Valence band, this type. VF. Okay, so exactly at x is equal to 1000 Armstrong, means it will become 10 to the power minus 5 centimeter. You have to find what is the Fermi level. So Fermi level, you have to find the concentration at this point. This gap, you can find Kt log of. No, you have to find the gap from what? Conduction band. You have to find this gap and then this gap. What is this gap? This gap is Kt log of Na by, or concentration of hole, divided by what? Ni. Concentration of hole divided by Ni. So in place of Kt you can use what? 0.026. P means what is the concentration at this point, you have to find from this formula. What is the exact concentration at 1000 Armstrong? Put here Ni 1.5 into 10 raised to power 10. Then you can find this gap. Now logic. What is the gap? This is this gap. This first one plus second one will give you the gap of this point from the conduction band. EC, it is asked. Gap from the conduction band, not from the valence band. This is asked. What is the steady state separation between FP and EC at 1000 Armstrong? Once you will get the gap, what is the whole current there? What is the whole current there? The whole current there, why we are getting the whole current? Because at the one side the concentration is high, at the other side the concentration is low. There is a diffusion phenomena. And because of diffusion, there will be the whole current, diffusion current, because there is a change in the concentration. So change in the concentration, if the whole current is asked, you have to find the diffusion current. So diffusion current density, I am just giving you the hint guys. Diffusion current is given by AJP. This will become minus AQ dp by dx. Now you have the value of A. Question given है 1.6 into 10 raised to power minus 19 Q. dp already we have calculated. dp by dx. So first of all differentiate it. First of all differentiate this equation. This term will become 0. You will get the minus sign. X upon LP. Differentiate it and finally put the value of the X. 1000 Armstrong means 10 to the power minus 5. And you will get the value of what? dp by dx with negative sign. Negative will become positive and you will get the diffusion current. Diffusion current. What is the whole current is there? The whole current is nothing but diffusion current. How much is the excess stored hole charge? Excess stored hole charge. Guys, you have to integrate it. You have to integrate it because it will become 0 at up to what? Infinity. When we are going to integrate it, this is the fixed value. Which one is the excess hole charge? This is the excess hole charge. It depends upon the x to integrate it from 0 to what? Up to infinity. 0 to what? Up to infinity, you will get the excess hole charge. It is the concentration guys. It is the concentration, number of electrons per unit volume, right? So excess whole charge is asked. So you have to multiply it with the volume, guys. So what is the volume of this strip? Tell me. What is the volume of the strip? It is nothing but A dot dx. Cross sectional area is same volume. This volume is multiplied with the concentration. You will get the number of holes. And when it is multiplied with the Q, it will give you the value of what? Charge. Excess hole charge is stored in that region. So this is a very, very good question. Try to solve this homework. Tomorrow I will solve in marathon session. This is the question from Streetment and Banerjee. Okay. Then if you find any difficulty, then please inform me. Now this is our last question. Again, this is just I am going to give you the hint. Gallium arsenide, Ga gallium arsenide at 300 degree Kelvin with an intrinsic concentration of this much contains the acceptor impurity atom at density of 10 to the power 15. Additional impurity atoms are to be added so that the Fermi level is 0.45 electron volt below the intrinsic level. The concentration and the type of additional impurity atoms will be respectively. The concentration and the type of the additional impurity atoms will be respectively. क्या होगा बताइए? Concentration and type of the additional impurity atoms will be respectively. Okay. So Fermi level is given. Additional impurity atoms are to be added so that the Fermi level is 0.45 below the intrinsic level. It is down by the 0.45. So you can find Ni is given, right? Contains the acceptor impurity atom at the density of 10 to the already intrinsic concentration is given. Already acceptor impurity atoms at density of 10 to the power 15 is given. Additional impurity atoms are to be added so that the Fermi level is 0.45 below the intrinsic level. So initially where is the Fermi level? The concentration and the type of the additional impurity atoms will be respectively acceptor or donor. So initially where is the Fermi level? Now it is 0.45 below. So where is the Fermi level? So read question carefully, guys. Always read question carefully. Just I am going to give you the hint. So initially we have no idea where is the Fermi level. But this is the case. This is the Fermi level below. In second case, now what is this gap? Kt log of Na by Ni. Na is given. 1.8 into 10 to the power 16. Ni is given. Acceptor impurity atom 10 to the power 15. It is given. Then you can find this gap. It may be more than 0.45. It may be less than 0.45. Now, according to new condition, the gap is what? Exactly 0.45. According to new condition, the gap is exactly 0.45. Right? For example, you are getting this point. So suppose it is what 0.25. You are getting the 0.25. Now it will become 0.45. So 0.45 means what? It is increases. So increases by what? 0.2. So you can find the new value and then you can find the, you can subtract and you will get the concentration, guys. Okay. So yes, you can find this value also. Kt log of Na by Ni. Now what is the new value here? Yes, directly you can also solve Kt 0.026, 0.45. So it will become Na is equal to Ni antilog of, antilog means e raised to power 0.45 upon 0.026. Okay, first of all I will find this, because automatically from this you will get whether it is added or subtracted. 0.45 divided by 0.026. Okay, then into 1.8, right, all multiplied with 10 to the power 6. 5.9 5.9 into 10 raised to the power 15 it is coming. Please check my calculation. Or initially what is the 10 to the power 15? 10 to the power 15. Or now what is the new concentration? 5.9 means 6 into 10 raised to the power 15. Means it is increased now. It is increased. So 6 into 10 raised to the power 15, and initially it is what, 10 raised to the power 15. Subtract. So around 5 into 10 raised to the power 15. This is the concentration we have added. Or it is goes down. It is goes down. No need to calculate it. No need to calculate, because the initial Na is less than this Na. We are adding the acceptor impurity, or around this is the but done the do the proper calculation here. Kt is given as 26 millivolt now. Okay, intrinsic carrier concentration is given this much. I have used na 0.026. Yes, what is the gap? 0.45 it is given. 0.45 electron volt below. 0.45 divided by this is the 0.026. Okay, use your calculator, virtual calculator, guys. Okay, and find the exact value. 1 minute. Again, I am going to calculate it. In second case, Daj, तो कैलकुलेट कर सकते हो. दैट इज अ वैल्यू. व्हाट क्या क्वेश्चन में क्या पूछा है पता है आपने? क्या ऐड किया, क्या ऐड करोगे कि भाई ये नीचे जा रहा है या ऊपर जा रहा है. तो पहले वाले से देखो, अगर दूसरे वाले से मैं डायरेक्ट कॉन्सेंट्रेशन निकाल रहा हूँ 0.45 से, तो Na की वैल्यू जो प्रीवियस वैल्यू से ज़्यादा आ रही है. अगर आपकी पहले से ज़्यादा आ रही है, मतलब आपने एक्स्ट्रा एक्सेप्टर इम्प्योरिटी क्या की है, ऐड की है. आपको पता है पहले आपने कितना ऐड किया था, 10 टू द पावर 15. अभी 0.45 के हिसाब से मान लो उससे ज़्यादा आ रही है, तो आपको उसको सब्ट्रैक्ट करके वैल्यू को कैलकुलेट करना है. यस, अब ओके. अब क्या प्रॉब्लम हुई है मैं समझ गया. दैट वैल्यू इज व्हाट, 5.91, राइट. 5.91. नहीं आ रहा, दिस इज नहीं है वैल्यू. अरे सॉरी यार, दिस इज व्हाट इज द 7 और 6. आई एम डूइंग द कैलकुलेशन मिस्टेक. 7 plus 6 is what, 13 na. This is 13 actually. It is nearly equal to 6 into 10 raised to power 13. So actually this is less than what, 10 to the power 15. So we are adding what, donor impurity. So how much donor impurity? 10 to the power 15 minus 6 into 10 to the power 13. Or you can write it what like that, 10 into 10 raised to power 15, 14, or 100. 10 to the power minus 14 into 6 into 10 raised to power 13. 13 power 100 minus 6, it will become 94 into 10 raised to power 13, or you can say 9.4 into 10 raised to power 14. So nearly equal to 9.4 into 10 raised to power 14. I will explain. So you are getting the 9.4 into 10 raised to power 14. Acceptor. No, donor. How? Now, please calculate it. What was the mistake? Just a silly mistake guys in calculation. Watch this. This gap is given 0.45. Directly find the Kt log of Na by Ni. So it will become Na is equal to Ni e raised to power 0.45 upon 0.026. It is nearly equal to 5.91 something into 10 raised to power 13. Okay. Now what was the initial concentration of Na? 10 to the power 15. So this is the 5.91 into 10 raised to power 13 is less than what? 10 to the power 15. So means this gap was more than what? 0.45. This is cancelled out. This is the correct one. Now if this gap is more than the previous one, so actually this gap reduces. So this gap reduces means we are adding what? Donor type of impurity. Donor will nullify the acceptor. It will reduce the acceptor. So Na minus Nd. So when we are giving the Na minus Nd is what? 10 to the power. Initially it is the 10 to the power 15. We are adding something so that the new concentration will become 5.91 into 10 raised to power 13. Right? And that's why it is moving upward. So initially the gap was high, now the gap is low. That is only 0.45. So what is the Nd? How much Nd is added? Donor. 10 to the power 15 minus 5.91 into 10 raised to power 13. Subtract it, or you can put here 100 minus 5.91. 100 minus 5.91. I think now it is clear. Okay, this will become this is the answer. Okay, so this is nearly equal to donor. Check calculation is nearby now. All the answer in the range of what? 10 to the power 13, 10 to the power 14 and so on. Please check it. Hope this is clear to you guys. This point is clear. Read question carefully and try to give the answer. Okay. So hope you enjoy the session. So guys, if you want to start your preparation with me, then चेक कर लो फ्रीक्वेंसी मैच हो रही है और लॉन्ग टर्म में आप अपनी प्रिपरेशन स्टार्ट करना चाहते हैं, क्वेश्चन अच्छे सॉल्व करना चाहते हैं, तो फॉर 2026 एंड 2027 यू कैन ज्वाइन मी फॉर इंजीनियरिंग सर्विसेज एग्जाम, फॉर गेट एग्जाम, live and recorded classes. You can call me at this number or you can message me at this number. So live sessions most important, recordings available in emergency, previous year question we will solve, questions from the standard textbook we will solve. Yes, there will be the definitely drought clearing sessions. In long term there will be the mock test also guys, right? Most important you have to get the command over the subject. हिंदी में भी अवेलेबल है और इंग्लिश में भी अवेलेबल है क्लासेस. क्या क्या होगा, क्या क्या कोर्सेज हैं, क्या फी स्ट्रक्चर है, फॉर मोर डिटेल यू कैन मैसेज मी एट दिस नंबर. ओके, स्टार्ट योर प्रिपरेशन नाउ. ठीक है, फ्रीक्वेंसी मैच होती है, अच्छी बात है, तैयारी स्टार्ट कर दो अपनी. एंड थैंक यू वेरी मच फॉर अटेंडिंग द सेशन. लाइक द सेशन एंड सब्सक्राइब द चैनल गाइस. ओके देन, थैंक यू एंड गुड नाइट.